Get ready for a deep dive into agile hardware with us today. It's a whole new approach to engineering and manufacturing, and some are even calling it revolutionary. We're going to unpack what it is, how it works, and what it could mean for the future.
It's really exciting stuff.
It really is. And you've probably heard of companies like Tesla and SpaceX that are already doing things differently in engineering.
Right.
And it turns out that's not a coincidence. There's a common thread here, a method that was really pioneered by an engineer named Joe Justice.
Yeah, Joe Justice. He's not just an engineer. He's a real thought leader.
Absolutely. And he's got this incredible background, designed his first car, the Wikispeed, right out of the gate, and then went on to work with Elon Musk himself, setting up agile practices at Tesla, consulted for SpaceX, and now he's working with companies like Toyota in Japan. This isn't some fringe idea. It's hitting the mainstream.
This is the real deal.
But before we get too far, can you give us a quick breakdown of what traditional hardware development looks like, just so we can understand what makes agile hardware so different?
Sure. Think about how long it takes to design and build something complex, like a car or a smartphone.
Okay.
Traditionally, that process can take anywhere from 2 to 7 years.
Wow, that's longer than I even realized.
It is a long time. And during those years, you have these huge teams working in separate silos: design, engineering, manufacturing.
Right.
There's a very linear progression. You design it, you engineer it, you test it, hopefully you manufacture it.
Right.
By the time it's actually in the hands of consumers, it could already be outdated.
Yeah, that's a recipe for a disaster in today's world.
Exactly. And that's where agile hardware comes in. It takes those long development cycles and breaks them down into much shorter, faster-paced iterations.
So instead of one giant leap every few years, it's more like taking many small steps every day.
That's a great way to put it. The goal is to have a constantly evolving product that's always improving based on real-time feedback and data.
And Justice argues that this leads to better products overall.
He says it's not even an argument. Think about it. If you're only testing a product every few years, you're likely to miss a lot of potential flaws or areas for improvement. But if you're testing and refining it every single day,
Right.
you're going to catch those issues much earlier, and you're going to end up with a much more robust and efficient final design.
That makes a lot of sense. It's like finding and fixing bugs in your code as you write it, rather than trying to debug the entire program after it's already been compiled.
Exactly. And this approach has been used successfully not just at Tesla, but also in aerospace, with medical devices, and even by major car manufacturers like Toyota. This isn't a niche thing. This has the potential to really change the world.
Okay, so it's faster, it leads to better products, but how does it actually work in practice? I imagine it takes a pretty radical shift in mindset.
It does, and one of the core tools of this methodology is something called the Justice Board.
Okay, literally named after Joe Justice.
Literally. And it's surprisingly simple. Imagine a big whiteboard or digital screen, more likely divided into rows and columns. Each row represents a different module of the product. So for a car, you might have a row for the battery pack, the motor, the seats. You get the idea.
Kind of like breaking down a complex project into smaller, more manageable chunks.
Exactly. And the columns represent key performance indicators, or KPIs, for each of those modules. These KPIs could be anything from cost and weight to energy consumption and efficiency.
Hold on, for those of us who aren't engineers, what exactly are KPIs again?
KPIs are like benchmarks or specific metrics that are used to measure the success or efficiency of something. So for a car battery, a key KPI might be how much energy it can store relative to its weight. For the car itself, a KPI might be how many miles it can travel on a single charge.
Okay, that makes sense. So each module has its own set of KPIs that are constantly being tracked and measured.
Right.
And what makes the Justice Board so special? What makes it different?
It's not just about tracking. It's about transparency and constant improvement. This board, with all its KPIs, is on display for everyone to see, and it's constantly being updated with real-time data. So you can literally see how a tiny change to the design of a car seat, for example, affects the overall weight, cost, and even the sustainability of the vehicle.
No more hiding in your cubicle hoping no one notices if your part of the project is behind schedule.
You got it. It keeps everyone accountable and focused on the shared goal of constant improvement.
And this ties into the idea of ditching deadlines in favor of daily improvement, right?
Exactly. Instead of working towards some distant deadline that always seems to be months or even years away, agile hardware teams focus on making small but impactful improvements every single day.
So instead of saying, we're going to revolutionize electric cars in 3 years, it's more like, let's see if we can make this steering wheel a tiny bit lighter today.
You've got it. And they're not just making random changes, they're using those KPIs on the Justice Board to guide their decisions. If
Yeah.
the goal is to reduce the car's overall weight, for example, engineers can experiment with different materials or designs, test them out, and then immediately see how those changes impact the KPI for weight.
That's really cool. Seeing those results in real time must be incredibly motivating for the teams. But how do they make those changes so quickly? I mean, if you're constantly tweaking and refining a design, doesn't that require a lot of retooling and reconfiguring of the manufacturing process?
It could, which is why modularity is another key principle of agile hardware.
Modularity, remind us what that means again.
Think of it like building with Legos. Instead of creating one monolithic product that's difficult to change, you design it as a series of interconnected modules that can be developed and improved independently.
So going back to the car example, instead of building the entire car as one unit, you might break it down into modules for the chassis, the powertrain, the interior, and so on.
Exactly. That way, a team working on improving the battery pack, for example, doesn't have to wait for the team designing the seats to finish their work. They can operate in parallel, which speeds up the development process significantly.
It's like having multiple assembly lines running at the same time, each one focused on perfecting a different piece of the puzzle. That makes so much sense. But I'm curious, can you give us an example of how this modularity thing has played out in the real world?
Absolutely. One of the most striking examples is the Tesla semi-truck.
Okay.
It's designed with 11 main modules, and because of that modular design, teams could work on each part independently, making improvements and adjustments on the fly without disrupting the development of other modules.
Okay, I'm starting to get a sense of how all these pieces fit together. The rapid iterations, the focus on constant improvement, the modular design. It's like a well-oiled machine constantly churning out better and better versions of the product. But there's one piece of the puzzle we haven't talked about yet, AI. I know from our prep materials that AI plays a huge role in agile hardware. What's the deal there?
Yeah, it's not just about using AI as a tool. It's about a deeper collaboration between humans and AI that Justice calls Mob AI.
Mob AI, okay.
Imagine a small, highly skilled team of engineers, say 3 to 5 people working together with a dedicated AI assistant.
So not just using AI for things like data analysis or simulation, but actually incorporating it into the design and decision-making process.
Exactly. And this isn't some off-the-shelf AI like you might use to write an email. These AI assistants are being trained and refined by the engineers every single day, learning the intricacies of the specific product or module they're working on.
So each team is essentially building its own specialized AI brain trust. That's pretty amazing.
It is. It's like giving each team an apprentice that never sleeps, can access and process information at lightning speed, and remembers everything it's ever learned.
Wow.
And this mob AI, it's being implemented at places like Tesla and SpaceX. This isn't a theoretical concept. This is actually happening.
It's happening now.
Yeah, it's very real. And Justice gives some fascinating examples of how it works in practice. One of the most vivid is the development of Tesla's heat pump.
Okay.
It started out, as these things often do, overly complicated and not particularly efficient.
Makes sense. You have to start somewhere.
Right. And in this case, the starting point was a design that was, according to Justice, a tangled mess of tubes and wires. But then they applied the principles of agile hardware and mob AI to the problem.
So they took this really complicated system.
Yeah.
And what happened?
Well, imagine a team of engineers gathered around a workbench at 5 in the morning. They apparently start their days pretty early.
Okay.
They've got their AI assistant pulled up on a screen, and their mission for the day is to make the heat pump just a little bit better than it was the day before.
I can just picture it. So they're not starting from scratch every day. They're building on the progress they made the previous day.
Exactly. They might analyze the data from the previous day's tests, looking for any anomalies or areas where the heat pump's performance could be improved. They might also consult their AI assistant, saying something like, "Show us the most efficient heat pump designs we've tested so far." Or, "What if we try using this new material? How would that affect the weight and cost?"
And the AI is able to pull up that information in real time.
That's the beauty of it. The AI acts like a super-powered research assistant, sifting through mountains of data and running simulations to help the engineers make informed decisions.
I bet that speeds things up considerably.
It does. And here's the really cool part. Every time the AI provides a helpful insight or answer, the engineers feed that back into the system.
So it's a continuous learning process, with the AI getting smarter and more specialized over time.
You got it. It's this constant feedback loop that allows the AI to become even more valuable asset to the team. And the results speak for themselves. Remember that big, clunky heat pump design they started with? After months of daily improvements guided by Mob AI, they ended up with a unit that was incredibly efficient and about the size of 2 pairs of shoes, according to Justice.
Wow, that's seriously impressive. It sounds like Mob AI has the potential to transform not just engineering, but any field that relies on complex problem solving.
It really does. And it challenges our assumptions about what AI can be. This isn't about replacing human intelligence. It's about augmenting it and creating a powerful synergy between human creativity and AI's computational abilities.
It's like having a constant brainstorming partner who also happens to have instant access to all the knowledge of the world.
Precisely. And what's even more remarkable is how this approach is changing the very nature of work itself. Remember all those separate teams and silos we talked about earlier?
Yeah, the designers, the engineers, the manufacturing folks, all doing their own thing.
Right. Well, in an agile hardware environment, those distinctions start to dissolve. We still have specialists, of course, but there's a lot more fluidity and collaboration.
So everyone's an engineer, in a way.
That's the idea.
Yeah.
Everyone is empowered to contribute their expertise, to move between tasks, and to work together towards the shared goal of creating the best possible product.
It sounds almost utopian, but I imagine it takes a special kind of person to thrive in that environment, this constant state of change and iteration, the pressure to constantly be improving. It must be pretty demanding.
It definitely attracts a certain type of personality. You need people who are adaptable, who are energized by challenges, and who are passionate about making a real-world impact.
I can see that it wouldn't be the right fit for everyone, but for the right person, it sounds incredibly exciting. It really does. But let's shift gears for a second and talk about something we haven't addressed yet: cost. This whole agile hardware approach, the rapid prototyping, the constant iteration, the AI integration, it all sounds, well, pretty expensive, to be honest. How can companies realistically afford to operate this way?
Yeah, that's a question a lot of people ask. And it's understandable, but Justice argues, kind of counterintuitively, that agile hardware can actually lead to lower costs in the long run.
Okay, how does that work?
Remember, we talked about those KPIs on the Justice Board?
Right.
And how the goal is to constantly chip away at those KPIs, making each module a little bit lighter, a little bit cheaper, a little bit more efficient every single day.
Right, those tiny gains adding up over time.
Exactly. Those incremental improvements, they might seem small in isolation, but when you compound them over time, they can lead to significant savings on materials, on manufacturing, even things like shipping and logistics.
So it's not just about making the product better. It's about making the entire production process more efficient and cost-effective.
That's a big part of it. And it's something that traditional manufacturing models often struggle with. They get locked into these long production cycles and inflexible supply chains, which makes it difficult to adapt to change or take advantage of new technologies.
That makes sense. But it still seems like there's a bit of a paradox here. We're talking about using cutting-edge technology like AI and highly skilled engineers to drive down costs. And that just seems like a recipe for higher prices, not lower ones.
It seems counterintuitive, but Justice argues that the opposite is true. He believes that as agile hardware becomes more widespread, it will actually drive down the cost of technology overall. Think about it this way. If you're constantly optimizing every aspect of your product and your production process, you're going to be able to create better products with fewer resources. And as those efficiencies scale up, the cost savings get passed on to the consumer.
Okay, so that's a pretty bold claim. Are we really talking about a future where products get cheaper over time, even as they get more advanced?
That's the potential of agile hardware, according to Justice. And it's not just about lower costs. It's about a fundamental shift in how we think about product life cycles. Instead of releasing a new version of a product every few years, imagine a world where products are constantly evolving and improving in real time.
So less about these big, splashy product launches and more about this continuous incremental progress that unfolds over time. I kind of like that idea.
It's a very different mindset, but it's one that's well suited to the pace of technological change in the 21st century. And we're already seeing this to some extent with software and digital services, where updates and new features are released on a regular basis. Agile hardware brings that same philosophy to the world of physical products.
It's like the difference between buying a CD and streaming music online. One is static and fixed. The other is dynamic and constantly evolving.
That's a great analogy. It really gets to the heart of what I find so fascinating about agile hardware. It's not just about making better cars or smartphones. It's about creating a whole new paradigm for technological progress, one that's faster, more adaptable, and ultimately more responsive to human needs.
We've covered a lot of ground in this deep dive, from the nuts and bolts of how agile hardware works to its potential to transform not just manufacturing, but also the very nature of work itself. It's a lot to process. As we wrap up here, what's the one big takeaway you want listeners to walk away with? What's the so what of all this?
The big takeaway for me is that we're really on the cusp of a major shift in how we design, build, and interact with technology. Agile hardware, driven by this powerful combination of human ingenuity and AI, has the potential to reshape entire industries, redefine what's possible, and ultimately create a world where technology is more aligned with human needs and aspirations.
That's a powerful vision for the future, and it makes you wonder, in a world where AI is becoming increasingly integrated into every aspect of our lives, what happens when companies are locked in a race to build not just the best products, but the most sophisticated AI minds to design them? What are the ethical considerations? What are the economic implications? And perhaps most importantly, how do we ensure that these powerful technologies are used to benefit humanity as a whole? Those are questions we'll continue to explore in future deep dives. Until then, keep asking questions, keep learning, and keep diving deep.